Hey everyone, today I'll be going over my solution for day 8 of Advent of Code. Day 8 is treetop treehouse, and the basics of this problem is that you're given a two-dimensional array with numbers, and these represent the heights of a tree because the elves want to build a treehouse. So they're looking for a good spot, and for example here, they want to know whether you can see a tree or not from the outside. So 5 you can see from the top and the left because 0 and 2 are less than 5. This one, 3 is less than 5, 2 is less than 5, so you can see it. 1 you can't see from the top or the right or the left because everything around it is larger than 1, as well as the bottom. This goes over all the conditions. So the question is, how many trees are visible from the outside grid? So we just have to, the general strategy we're going to go through is we're going to add all the border trees, and then we're going to go through and do exactly what I just did for each tree within the border, incrementing our sum as we find trees that are visible. Let's hop into the code. I'm going to import the read file sync from file system library. That's a function. We're going to use that to open the text file. That looks like this here. So this is my input. And the strategy to get this is we're going to declare an empty array called forest, and each individual line we're going to read in as its own array. So we'll create our two-dimensional array. So we call file.split on the new line character to get those lines, and then we're going to loop over every line within lines. We're going to split that on basically the empty string, and we're going to map that to an int because we want that string to be an int. And then we're going to push that to that array called forest. And now we have our two-dimensional array. Next, we want to get the number of rows, so that's forest.length. And we'll get the number of columns, which is forest of 0.length. I forget if it's square grid or not. But anyways, doesn't matter. Now we'll initialize this variable sum with all the border trees, which are always visible. So to get the border trees, we just take numRows minus 1, multiply that by 2, and numCols minus 1, multiply that by 2. Okay, let's define a function called checkTree. I'm going to zoom in just a little bit here. This returns true if a tree is visible from any direction. And so the input is going to be the row and column of a tree, which is a number, and it's going to output a Boolean true or false. So we'll get our tree height, which is the the specific row and column that we're looking at. And then we're going to define a variable called left, and we're also going to use this function called checkLeft, which we haven't written yet, but we'll write in a second. And that's going to take in the row, the column, and the tree height at that row and column. And if left is true, then we just want to know if the tree is visible from any direction, so we can stop checking the rest, and we'll return true. And now we're going to do the rest for the right side, the up direction, and the down direction. And then at the end, if we've checked every direction and we didn't find visibility in any direction, then we return false. This checkTree is going to be used in our main function, which I'll show you in a minute. But first, let's go ahead and define this check left, check right, check up, and check down. So check left is a function that takes in a row, a column, and tree height, as we described earlier. Those are all numbers. And the very first thing we want to do is we want to check to the left of our current cell. So we're going to decrement the column variable. And we're going to set a boundary condition. While that's greater than or equal to 0, we want to check if the forest row and column of that particular cell is greater than or equal to tree height. If it is, then we know the tree is not visible, right? So we can just return false. Otherwise, we're going to decrement column again and continue with our while loop until it's at the last tree there on the left side. And if we checked every cell to the left and we did not find a taller tree, then the tree is visible from the left, so we can return true. And now I'm just going to do, basically it's the same logic for right, up, and down, but you'll notice that for checking right, we increment column and our boundary condition changes. We want to make sure that the call is less than or equal to number of columns minus 1. Checking down, we're going to increment row, and we're going to check that it's less than numRows minus 1. And then checking up, we're going to decrement row, and we're going to make sure that it's greater than or equal to 0. So just repetitive logic for each direction. I like to break it up though, just so I can see everything that's going on. And now we're going to do our kind of main logic here that's going to use all those functions we just defined. So we're going to use a nested for loop. So first we want to loop through all of the rows within our forest, and then we're going to loop through all the individual columns so that we can go through each cell individually. And notice here I'm doing numRows minus 1 and numCols minus 1, and I'm starting from 1. This is because I don't want to account for those border trees. So this is just inside the border. We already accounted for all the border trees being visible. And now if they're visible, so I'm going to call check tree of row column, then I'm going to increment sum, and then I'm just going to console log sum here. And let me go ahead and build, and we will go ahead and run this. And we get 11713. Check the answer. Puzzle answer was 1713. For part 2, we're going to calculate a scenic score for the trees. Now the elves want to see what it's like looking out from each tree and whether they can see more trees. So the question says, what is the highest scenic score possible for any tree? And you can see, like, consider the tree of height 5 in the middle of the 4th row. So this tree here, its view is blocked at 2 trees by another tree with a height of 5. So it's blocked here, and it's blocked by 9. So the scenic score is 8, which is, I think, how many trees you can find in each direction multiplied by each other. So let's go ahead and code that out. It's going to be very similar to what we coded all up here, but we're going to modify all the code slightly to return a score rather than a Boolean. So for part 2, let's initialize our max scenic score tracker with a value of 0. We're going to look out from each tree. If we reach an edge or the first tree that is the same height or taller than the tree under consideration, then we know that to stop adding to our score. So let's define a function called check tree score, very similar to check tree, takes in a row and a column and returns a number. We'll get the tree height, same as we did before. Now we're going to check each direction. Now we're not going to return after any direction because we want to get all the scores and then multiply them together at the end. So we have this function that we'll define in just a minute, check left score, check right score, check up score, check down score, and then at the end we're going to return all those multiplied by each other, just as we showed for the answer. Now let's define a function called check left score. This takes a row, column, and tree height. Very similar to check left. Now what we're going to do is we're going to initialize a variable called score and set that equal to 0. We're going to decrement column. This is all very similar. Same boundary condition. We're going to add to score. If the cell is taller than the tree, then the screen is not visible from the left. So we're checking here that if that particular row and column that we're iterating through is greater than or equal to tree height of the tree under consideration, we just return score and we exit from our function. Otherwise, we reduce column by 1 and we continue with our while loop. And at the end of the while loop, we're going to return score. Same thing for check right score. Again, the boundary condition changes, and whether we're incrementing or decrementing changes. Check down score, same thing. Check up score, same thing. And now we're going to run our main nested for loop, same as we did before, but this time we're going to set a variable scenic score equal to check tree score. And we're going to say max scenic score is the maximum of scenic score and max scenic score. So it just updates the maximum as we iterate through our forest. And then let's go ahead and console log that. And we'll go ahead and run again, and I get 268,464. Check that against my answer, and that's right. And then you get 2 more stars, and I'll see you for day 9. Thanks for watching. Bye-bye.
Yeah.